Welcome back, everyone, for another deep dive. This time, we're looking into something really fascinating. It's cluster processing.
Yeah.
And I think it's something that even if you're not, a computer programmer or anything like that,
Right.
you can really wrap your head around it, and it powers so much of the technology we use every day.
Absolutely.
So to get started, maybe you can tell us a little bit about cluster processing and what problem it tries to solve.
Sure. So cluster processing really tackles the problem of having too much data.
Okay.
Too much data to process on a single computer.
I can imagine that would be a problem.
You can imagine like in scientific research or financial modeling,
Right.
even things like rendering video game graphics.
Oh, wow. Yeah.
If you just have one computer trying to crunch all that,
Yeah.
it's going to take forever.
Yeah, that makes sense.
So that's where cluster processing comes in.
Okay, so how do clusters change that? How do they get over that?
Well, you can kind of think of it as teamwork.
Okay.
But for computers, so instead of having one computer struggling to do everything,
Right.
you have a whole network of computers
Gotcha.
all working together. Each one takes a small chunk of the data,
Okay.
processes it.
Kind of dividing and conquering?
Exactly. It's like dividing a giant pizza.
Okay.
Way faster to eat it together.
Right. Yeah, that makes sense. But if you have all these computers working together, wouldn't that be kind of chaotic?
That's a great question.
How do you keep them all coordinated
Yeah.
and make sure that the data is processed correctly?
Yeah. So that's where this really important concept of a task leader comes in.
Okay, task leader.
Yeah. Think of the task leader like the conductor of an orchestra.
Okay.
Right? It's one who's assigning tasks to the right, quote unquote, musicians.
Right, the workers.
Exactly. The workers, making sure everyone's in sync.
Gotcha. So you have the task leader who's kind of like the boss.
Yes.
But who are the workers then in this orchestra?
Well, the really neat thing about cluster processing is that any computer on the network can be a worker.
Really?
So that old laptop you might have in your closet
Right.
could be crunching numbers alongside, some powerful supercomputer.
Wow. So my laptop could be part of some big data project and I wouldn't even know it.
Exactly. And that flexibility is what makes cluster processing so powerful.
Okay.
You can scale it up or down,
Yeah.
depending on how much data you need to process.
That's really cool. But if you have all these different computers working together, wouldn't they all need access to the same data?
Absolutely. They need some way to share the data.
So like a shared drive or something?
Yeah, you can think of it like a giant digital library.
Okay.
Where all the computers can both read from
Right.
and write to.
So it gets a little complicated.
It does get a little bit complex.
Yeah.
Because you have to think about how to keep that data consistent and secure.
Right. I can
Oh.
see how that would be a problem.
It's like making sure everyone in that library has the right edition of the book.
Right. Yeah.
And no one's sneaking in any unauthorized pages.
Okay, so back to the task leader then.
Yeah.
What's it doing all day to keep this orchestra?
So the task leader is a very busy entity, let's say.
Okay.
It has several important responsibilities. First of all, it needs to keep track of all the workers.
Right. Check in with them.
Yeah, it needs to constantly check in,
Make sure they're still there.
see who's available, who's busy with something else.
Right.
Then have to look at all the tasks that are coming in,
Okay.
analyze them, and then assign those tasks
Okay.
to the appropriate workers.
So it's not just any worker gets any task.
No, it's very strategic about it.
Okay.
It tries to match the skills of the worker
Right.
to the requirements of the task.
Really optimizing the whole thing.
Exactly. All about optimizing the process.
Wow.
And at the same time, the task leader is also keeping an eye on all the tasks that are in progress.
Gotcha. Making sure everything's going smoothly.
Yeah. Making sure there are no delays, no errors.
So it really is like a conductor then.
It is. It's juggling all these different elements.
Wow. And what happens when a task is finished? What happens then?
So when a worker finishes a task, it sends the results back to the task leader.
Okay.
So the task leader is collecting all these different results.
Okay.
It's piecing together the puzzle.
Right.
And then it delivers the final output, whatever that might be.
Okay, and that could be anything from like research data to like CGI for a movie or something.
Exactly. It could be all sorts of things.
Yeah, that's really cool. You mentioned earlier that the task leader gets even more detailed in its management.
Yeah.
It actually goes down to the level of individual processor cores.
That's right.
I'm not quite sure I follow that.
So most computers these days have multiple cores.
Okay.
You can think of each core as like a mini brain
Okay.
that can work on a task.
Okay.
And the task leader is so efficient that it can assign tasks
Yeah.
to individual cores within each worker.
Wow. So it's squeezing every last drop of power out of the cluster.
Exactly. It's maximizing efficiency. That granular control is what allows clusters to tackle these really massive problems
Okay.
that would just choke a single computer.
That's amazing. So we've talked a lot about the task leader now.
Yeah.
What about the workers? What are they up to?
Well, their roles are absolutely crucial, even though they're not in the spotlight.
Right.
Let's dive into their world a little bit more. So the workers, they might not have the conductor's baton or anything, but they're the ones who keep this whole system running.
Okay, so what does a task worker actually do? Like, what's their day-to-day look like?
Well, their main job is to stay in touch with the task leader.
Okay, so just like checking in, making sure.
They're constantly checking in.
Okay.
Saying, hey, I'm available. I'm ready for my next task.
Right, so they don't miss their cue.
Exactly. You don't want to miss your cue in this orchestra.
Yeah.
And then once they get the signal from the task leader,
Yeah.
they receive their task with all the instructions on how to execute it.
So they're kind of like specialists then?
You can think of them as specialists.
Yeah.
Each one has their own little area of expertise.
So what kind of tasks are we talking about here? Like, what are some examples?
What could be anything, really.
Okay.
Imagine you're analyzing astronomical data,
Yeah.
trying to find new planets.
Right.
A task worker might be responsible for processing a specific slice of the night sky,
Wow.
looking for telltale signs of a distant world.
So each worker is contributing to a potentially huge discovery.
Exactly. It's pretty amazing when you think about it.
That is pretty amazing.
Or think about rendering a complex scene in a video game.
Okay.
One task worker might be focusing on lighting effects.
Okay.
Another one might be doing character animations.
Right.
And yet another one might be working on the environmental details.
Okay.
So they all come together to create that final product
Wow.
that you see on your screen.
That's so cool. So once a task worker finishes its task, what happens then?
Well, they need to report back to the task leader.
Okay.
Send the results back, say,
Now
hey,
I'm done.
gotcha.
Here's my piece of the puzzle.
So it's like a constant cycle of communication, execution, and delivery.
Exactly. That's a great way to put it.
And you mentioned earlier that the task leader manages tasks down to the level of individual cores.
Yeah, that's one of the really amazing things about cluster processing.
Yeah, it kind of blew my mind a little bit.
Well, the same thing happens within each task worker.
Really?
A single worker might be juggling multiple tasks at once,
Okay.
each one running on a different core.
So it's like each worker has its own little orchestra going on.
Exactly. It's like a mini orchestra.
Wow. That's incredible.
And that's what allows clusters to achieve such incredible speeds.
Okay.
They're doing so much in parallel.
Okay. I see. So we've been talking a lot about the technical details,
Yeah.
but what about the real world impact?
Right. Good question.
Where do we actually see clusters making a difference?
Well, think about all the things we use every day that involve massive amounts of data.
Okay.
For example, artificial intelligence. Oh, yeah. AI. Everyone's talking about AI these days.
Yeah. AI is a hot topic.
But I have to admit, I don't really understand how it all works.
Well, a lot of those AI breakthroughs you hear about,
Yeah.
they rely on complex algorithms
Okay.
that need to process huge amounts of data.
Right.
And that's where clusters come in.
So clusters are what make AI possible.
They provide the heavy lifting, you could say.
Wow. So without clusters, we wouldn't have the same level of AI advancements.
That's right. They're essential for a lot of AI applications.
That's pretty incredible to think about.
It is. And it's not just AI.
Okay, what else?
Think about those personalized recommendations you get
Oh, yeah.
on streaming services or online shopping sites.
Right.
Those are also powered by algorithms
Yeah.
that analyze huge data sets of user preferences.
Right. To figure out what you might want to watch or buy.
Exactly. And all that processing happens on clusters.
So clusters are kind of like the unsung heroes then.
Yeah, you could.
They're working behind the scenes to make all this stuff happen.
Absolutely. And as we generate more and more data.
Right, because it seems like everything's becoming more data-driven.
Exactly.
Yeah.
The role of clusters is only going to become more important.
Okay.
Think about scientific research,
Okay.
analyzing genomes, simulating climate change,
Right.
searching for new particles.
Right.
All these things require massive computing power.
So clusters are really driving scientific discovery forward.
They're helping us make sense of the world around us,
Wow.
from the tiniest particles to the vastness of the cosmos.
That's incredible. So where do you see this technology going in the future?
Oh, that's a great question.
What are some of the possibilities that we might see down the road?
Well, the possibilities are almost limitless.
Okay.
As clusters become even more powerful and sophisticated,
Yeah.
we can expect to see even more groundbreaking applications
Like what?
in fields like medicine materials, science energy research.
So we could be talking about things like personalized medicine
Exactly.
or developing new materials with crazy property.
Right.
That's amazing.
And as AI and machine learning continue to evolve,
Yeah.
clusters will be essential for training even more complex algorithms.
So clusters are going to play a key role in shaping the future of pretty much everything.
I think that's a fair statement.
Wow.
They're the workhorses of the digital age.
This has been a real eye-opener, I have to say.
It's been a pleasure talking about this with you.
It's amazing to see how something that seems so complex can have such a huge impact on our lives.
Absolutely.
So to our listeners out there, we encourage you to keep exploring this topic.
Yeah, definitely.
Think about the challenges in your own field or areas of interest.
Right.
Could cluster processing be the key to unlocking new solutions?
The answers might surprise you.
That's a great point.
Remember, innovation often happens at the intersection of different fields and ideas.
That's very true.
So keep learning your stuff, keep asking questions, and who knows?
Yeah,
Maybe you'll be the one to pioneer the next groundbreaking application
that's a great note to end on.
with this remarkable technology.
Well, that's a wrap on our deep dive into cluster processing.
Thanks for listening, everyone.
We hope you enjoyed the journey.
We'll see you next time.
Until next time, keep exploring, keep questioning, and keep diving deep.